Okay, we're back in the chemistry classroom again, ready to do another chemistry demonstration. As always, back behind the camera, my son Ethan. Say hi, Ethan.
Hello.
So today we're going to look at the combustion of a gummy bear. And really it's combustion of sugar. And really one of the reasons why we do this is to sort of visually see how much chemical energy is found, let's say, in a gummy bear. This Casey's brand gummy bears here. So we measure food energy in calories, big C calories. So each gummy bear has about 7 big C calories. I say big C, that actually means kilocalories, or about 7,000 small c calories. But we'll be able to visually see that amount of energy released. You know, I could take a gummy bear and just take the torch of science and light it on fire to kind of smolder and burn kind of slowly. But if we want to release all that energy fairly quickly, we have to do it a different way, and we'll kind of show you that. So we're going to take some potassium chlorate. If you remember from your polyatomic ions, chlorate is ClO3. So potassium chlorate, we're going to decompose potassium chlorate. And we're going to heat that in a test tube to decompose it. So we start with potassium chlorate, and we're going to decompose it into potassium chloride and oxygen gas. And here's really what we're after, this oxygen gas. So when we take the gummy bear, which is mostly sugar, sucrose, C12H12O11, it's going to be in a very oxygen-rich environment. And there's also going to be, well, we're going to heat this up, so it's going to be high temperature, fairly high temperature, and we're going to have an oxygen-rich environment. And this gummy bear, this sugar, is going to go through a combustion reaction. If you remember combustion reaction, the products, in this case, a hydrocarbon, is going to be carbon dioxide and water and a lot of heat. We're not going to get into the quantitative part of how much energy, but just visually, we'll be able to see what that 7 calories look like. Now, if you take a gummy bear and you eat it, you know that it has chemical energy, and sugar is very energy dense. It has lots of energy. You know, if you eat too much gummy bears, you know, you're probably going to put on some weight because you're going to have excess caloric consumption, and your body's going to store that. So sugar has a lot of energy, and hopefully we'll be able to see that visually with this chemical demonstration. Let's go back to the fume hood and try it out. We have our potassium chlorate in a test tube. I've got the torch of science here, and we're going to decompose the potassium chlorate, and the products will be potassium chloride and oxygen gas. So that is what we're doing right now. We're heating up the potassium chlorate. It's going to be turning to molten potassium chlorate, and then we'll start decomposing. Here is my gummy bear that I'm going to use. I was told by my son Ethan that I should use yellow because yellow is his least favorite because he wants to eat the rest of them. So we're going to sacrifice the yellow gummy bear. So it's starting to turn to a liquid here, not all of it, but we want it to turn to a liquid. At that point in time, we know that the decomposition reaction is underway and is going. Then I will take the gummy bear and we will put it in the test tube. Sometimes it gets stuck a little bit, so sometimes I will have to push it down with a glass stir rod. So we will keep on heating this up. I want you to look to see what color the flame is when we see this. And it may make you remember of a different time we saw this color of flame. So, and think about maybe what would be getting hot, what elements are getting very hot. So I want you to think about that. Get back behind here, this side, heat it up. So we're getting close. You can still see some solid potassium chlorate. We don't want to heat it too quickly. We're getting pretty close. So once the sucrose starts to combust, it happens fairly quickly. So those 7 calories get expended fairly quickly. All right, that last little bit is now turning molten here. So we probably can't see it on camera, but there's bubbles happening. I'll turn this off. We're gonna take the gummy bear, my glove here, gloved hand, and like I said, I'm probably gonna have to this. Gummy bears are sticky. That's some major heat going on right there. So that is that energy, that chemical energy stored in that gummy bear, really the sucrose. And it's still releasing energy. You notice there's a little bit of that pinkish purple color, indicative of the potassium. If you remember, we did the potassium chloride, that flame test. That would have been similar to the potassium chloride or that potassium flame test that we did. Turn the fume hood off. So within maybe 10 seconds, we saw that gummy bear, or that sugar, release about 7 calories of energy in very visual form. It'd be very, very hot right now. I've actually done this. It's gotten so hot that it's actually melted the rubber on the test tube clamp a little bit. So we're gonna let that cool. So I hope you enjoyed that demonstration, and we'll see you again next week.